next problem is called k closest points to the origin, and we are given an array of points where basically each point is represented by x and y coordinates in the xy plane, and an integer k where basically we have to return the k closest points to the origin marked by 0 and 0. This is between 2 points of the xy plane in the Euclidean distance, and basically Euclidean distance is calculated as the square root of the difference between the corresponding coordinates. So we are decrementing the coordinates x and the coordinates y, and then we are also squaring them. So it's that's the formula that we'll be using to calculate the distance between 2 points. We may return the answer in any order. The answer is guaranteed to be unique, except for the order that it is in. Now for the example, we have the 0.13 and minus 2, 2. And as we can see, if we draw this line, we can see that the point minus 2, 2 is closest to the origin. We can check that by the formula, and because we only have to return the most closest point to the origin, we just return minus 2, 2. The constraints are that the number of points is larger than the k, and they are both between 1 and 10 to the 4th. And so we are looking some solution in the either time complexity, in either linear time complexity or n log n time complexity. And the x and y coordinates are from minus 10 to the 4th, 10 to 10 to the 4th. Now, when we have the closest or the farthest, or the minimum or the maximum, we have to choose like a subset of some elements given by the input array based on some criteria that's like either closer, the farthest, the minimum, the maximum. The data structure that's really handy is actually priority queue, and the priority queue enable us to have either the maximum or the minimum element at the top. So it enables us to easily remove or retrieve the maximum or the minimum element. How can you use this to find the closest numbers, the closest points to the origin, or the minimum k minimum numbers or something like that? So it's always you can remember it by the fact that if we are looking for the closest, we will be looking at the max priority queue. If you are looking at the farthest, you will be looking at the minimum priority queue. So it's basically vice versa. It's in reverse order. Why is it in reverse order? Basically, if you are traversing over the array of points and you are keeping the size of the queue to be k, which is the number of candidates that we have to return, number of k points that are the most closest to the origin, if we are always keeping the size to be at maximum k for our queue, and when it goes over, we will be extracting the maximum element by some criteria. In this case, the element that will be top of the priority queue will be the element that's most distant from the origin. So that has basically the highest, like the largest distance from the origin. So after we have traversed through the whole array, the k candidates that have remained inside the queue are actually the candidates that have never been at the top of the maximum queue. That means that all the elements that we had discarded for the queue are the elements that are maximum, that are larger in distance from the origin than the currently k placed elements in the queue. And because we are looking at actually the k closest, we know that these k elements in the queue are the k closest elements to the origin, because we have discarded all of the other elements that are further from that have a larger distance from the origin than these k current elements. So basically, that's what we are going to do. We'll traverse the points array, and each time we will basically just keep the length of the queue, priority queue, to be smaller or equal to the k, and if it's larger, we will just discard the element at the top, which is basically the maximum distance from the origin element. And finally, we will just convert the queue to the array, so we can return the array of the points that are k closest points. Now, the operations on the queue are in the logarithmic in logarithmic relation to the number of elements in the queue. So the operations that we will have will be logarithmic to relation to the k, because k is the maximum elements that we will have in the queue. And because we are traversing through n elements, for each element we will have this operation. So the total time complexity will be n times logarithmic of k. Next, for the space complexity, because we can have at most k elements in the queue, we will have k for space complexity, where k is the elements inside the queue. So first we will declare our priority queue, and we have to define a custom comparator for the elements after they have been inserted, so the queue can have the order of the elements and actually keep the maximum element at the top. As you can see, we are first placing the B element, not A minus B, but B minus A, because we want to have it in the reverse order. We want to have a max priority queue. The default one is actually A minus B, which is basically corresponds to the minimum priority queue. So basically that means that the element at the top will always be the minimum. But in our case, we want to have the maximum, the element that's the further distant from the origin. And to do that, we have this relation basically where we are calculating the Euclidean distance. As you can notice that we are not using the square root, because basically we don't need it. The square root, if the element at B, B, basically point B, is further from point A, the square root will be still positive number, because that the difference will be positive, because B is larger and then more distant than A. So we don't need the square root. We can just keep it without it. Next, we'll traverse through the points array, and for each point, we will add it to the queue. We will check if the queue size is larger than k, and we will discard the element that's at top, the most distant element we currently have. Finally, after we have traversed all the points in the array, we know that the current k elements in the queue are the k closest elements to the origin based on our custom comparator in the priority queue. So we just have to convert the priority queue to an array. We do that by calling toArray method, and we are passing the desired format. So the desired format will be an array of k elements, where each element has two elements, basically corresponding to x and y coordinates.